Good afternoon, everyone. Thank you for your patience. Ryan's in back-to-back meetings, so it was a quick dash to this next session. So we've got Ryan Loney here and Sean Pryor. Sean's a great partner of ours with Red Hat, and we are here to talk about optimized speech recognition with OpenVINO and Red Hat OpenShift Data Science. So a lot of exciting stuff in store for this session. So let's go ahead and get started. Thanks all.
Cool, thanks, Ansley. So I'm really excited about this session because it's always so much fun to work with Sean, and Sean's a software developer, so he's gonna really make this a fun, geeky tech session and show you real code. So if you look at the handout section, you'll see that there's some links. There's a link to a blog that has all the code that Sean's gonna show today, and a link to a developer sandbox where you can actually try and run in OpenShift and install OpenVINO, deploy the service, and do speech recognition. So I'm Ryan. If you've been watching the other sessions, you've probably heard my intro, but I'm a product manager at Intel for OpenVINO, and really fortunate to have Sean here today, who's a senior software engineer from Red Hat, and we've been partnering on OpenShift Data Science, which is a product from Red Hat. So Sean, can you tell us a little bit about OpenShift Data Science and introduce yourself?
Yes. Hello, I'm Sean Pryor, Senior Software Engineer from Red Hat, and I am here to talk about Red Hat OpenShift Data Science and all of the stuff that entails and integrating it with OpenVINO. It's always great to work with Ryan. My camera's reversed. You're over here. It's always great to work with you. Yeah. Right. So, yes, let's hop into it, I guess. So, Red Hat OpenShift Data Science, or ROADS, is our managed cloud service on top of our managed OpenShift service. So if you've already got managed OpenShift, you can add on Red Hat OpenShift Data Science for all of your data science needs. It's got all your standard Jupyter Hub for your Jupyter notebooks. It's got all the training and other things you might need. And if you include the OpenVINO operator, it does model serving, as well as optimization and all the other fun things that Ryan will tell us all about very shortly. And as you can see here, the slide just covers all of the different offerings that we have here. Primarily, managed OpenShift is on AWS right now, but other clouds will be there in the future. And you can get this right now. It's live. You can order this, and there's a sandbox that you can try it out very shortly. At the end of this presentation, we'll show the links and stuff as well.
So Sean, for
So,
somebody who doesn't maybe know about OpenShift, like what's the maybe elevator
oh,
pitch or the sort of high level, why would you need OpenShift? Is it like Kubernetes?
yes, OpenShift is the Red Hat version of Kubernetes. It's got your standard Kubernetes interface, kubectl works against it, etc. But it's hardened. The software stack is gone through the standard Red Hat hardening all the way from the applications, if they're using UBI based images, all the way down to the firmware. All of that nice Red Hat security goodness that everyone likes. Other than that, it runs pretty much the same way standard Kubernetes does, and it has all of the stuff you'd expect, as well as operators which can enhance and add other features on top of it.
Cool.
And then on top of that, you have Red Hat OpenShift Data Science for your other managed service that can give you all the data science specific stuff. And it comes with things like Apache Kafka streams you can do other database things, etc., etc. Speaking of operators, let's talk about the partner ecosystem. Because no big important piece of software is complete unless you have a nice catalog of partners that can put their software on it and enhance the value offering to everyone. And so, of course, you've got Intel here, but as you can see, there's a ton of logos here, and they have all kinds of stuff from the databases to the data cleaning and preparation to the life cycle management of models to all kinds of things like that, serving let's see, and a couple of others if you need fully external services, like Starburst has its own external thing, Anaconda, which I also work on. Let's see. And all of this on top of a platform that will give you NVIDIA and eventually, whenever it gets released, Intel GPUs. And all of that powered on top of whatever cloud infrastructure you want. Currently AWS, but others very shortly after. And that gives you all of the additional tools for anything in the data model development, app dev, or monitoring spaces. I don't know.
Cool.
Was there anything else I needed to say about that? I think we're good,
It's a lot
right?
to absorb, but I think the next slide will help us understand the OpenVINO piece a little bit.
Yeah, specifically, one of these partners is Intel, little tiny semiconductor manufacturer. You guys may have heard of them in the past. So I'm going to kick it over to Ryan to talk about OpenVINO.
Cool. Yeah, so we've done a little bit of work. Well, we've done a lot of work, I think, in partnering with Red Hat over the past few years. And one of the
Definitely.
things Sean mentioned was the operator. So operator framework is something that exists in Kubernetes and OpenShift, and it's for offering services that are compatible and can run in this container orchestration environment like OpenShift. So we took OpenVINO, we had a Helm chart for deploying in Kubernetes, and we decided let's make this native for OpenShift and offer it through Red Hat's catalog and through Red Hat's marketplace. And that's what we have with the OpenVINO operator. So this enables you to take OpenVINO, install it directly in an OpenShift environment, and manage resources. So if you want to deploy a model and serve it over an inference endpoint, you can do that directly through the OpenShift console. You can deploy your model, serve it, scale it, run it with service mesh. And this slide here sort of shows the benefit of using OpenVINO, because you may want to deploy it on Xeon servers with many CPU cores. You might be deploying it at the edge on an integrated GPU or on an Intel core processor on the CPU, and you want it to run efficiently regardless of where you run your model. So converting to OpenVINO format give you a representation that you can run in the cloud or at the edge, and the OpenVINO is going to take care of making sure you get the best performance. We mentioned the auto plugin in some of the other sessions today. So all of these features that exist in the latest version of OpenVINO, you can leverage them directly through OpenShift, deploy your models, manage your models, serve them at scale, and get the benefits of OpenShift and OpenVINO together. Anything
Definitely.
to add, Sean?
Yeah, OpenVINO also has some very interesting optimizations it can apply to these models. Isn't that right?
I do, yeah. So yeah, out of the box, OpenVINO is when you optimize a model, we're applying operations, convolutions, fusion to take the model without impacting the accuracy and give you better performance than you would get just right after you train the model in a deep learning framework. So you get this optimized format. We drop some of the layers that were only used for the training phase to reduce the size, reduce your memory consumption, reduce the footprint of the model. And then if you want to take it a step further, we have tools for quantization. So post-training quantization, quantization-aware training, if you need to get additional performance or you want to compress the model further. And so all of those are available, these tools are available through OpenShift. If you have OpenShift Data Science, you can install the OpenVINO operator, get access to our Jupyter notebooks, learn how to start optimizing the models, compressing them with our quantization tools, benchmarking them. You can do that all directly in the OpenShift Data Science.
Yeah, definitely. And you can also use this to optimize for different hardware footprints than what it was trained on. Is that correct?
Yeah, so typically, I mean, very often the models are trained on a GPU, and hopefully soon Intel GPUs, like Sean said. But today, that's where the models are being trained, and so you may want to deploy it on an Intel core processor, an Atom processor, a Xeon, or integrated GPU. Soon our discrete graphics, and it's really leveraging the plugin architecture of OpenVINO, we're going to provide a format that you can run regardless of whether you're using the GPU, the CPU, if you're using a low-powered device or using a server class CPU, you're going to get all of the benefits of what's under the hood, whether it's our Intel DL Boost, AVX 512, DP4A, and the GPU. There's all of these different hardware optimizations that you can take advantage of, and we're just unlocking those with OpenVINO.
Hell yeah. Well, I guess, is it time? Are we ready to show the public what they've been waiting for?
Show the code.
All right. Well, here is our demo in just a moment. Ta-da! So, I'm going over here onto my Red Hat OpenShift Data Science cluster, where I've got an OpenShift dedicated cluster with Red Hat OpenShift Data Science installed already, and as well as the OpenVINO Toolkit operator and some other stuff, because this is also a cluster I do development work on. But that's the important part, is we have the OpenVINO Toolkit operator. You can go right over here to Operator Hub, click OpenVINO, and then click, this would be an install button if I didn't already have it installed, right there. That's how easy it is to get. And if you go here, you'll find that it provides two things, Model Server and an optimized Jupyter Hub notebook. So if we go over here to the OpenShift Data Science dashboard, we'll see in Jupyter Hub we have the OpenVINO stuff here. And let's get into our code. So this is a variant of the standard speech-to-text with OpenVINO notebook. It's 211 speech-to-text. I'll show where that can be found for those that don't already have this. But the Intel notebook comes preloaded with a ton of these things, as you can see. And there's actually been a couple more since I last refreshed this, I'm sure. So if we go here, we see standard thing. It's using QuartzNet as the model. So we go through. God, that runs. So we have our standard inputs here. We have the OpenVINO inference engine import. This, we're not going through the entire notebook because I've added some things to do it in a slightly different way to make use of the OpenVINO model server, but a notebook variant of this will be published at the end. So we have our standard file paths, and we can run our downloader here, which will produce a QuartzNet model, standard Onyx format model. If we go back here, we then can go ahead and run this converter, which will turn it over into OpenVINO IR format, which is right here. These three files are the ones you'll actually need when doing OpenVINO. And with that, we have downloaded and converted our model over. So now we can upload it into S3. Oops. So we have our Boto3 imports here, same stuff from the other notebook, and the same paths that we created earlier, which is just all variables. And for the purposes of this, we're actually using a little Ceph instance because of reasons I don't actually have an S3 account right now. But imagine that this is really S3. And so we would
you're uploading the models to a model repository, and that way every time you deploy an instance of this, the server knows where to pull the model artifacts from, right?
Precisely. So we will have in our layout, as I'll show here in just a moment, we will create our client and upload the bin mapping and XML files. The bin file contains the model weights, the XML contains the layout, and the mapping file has some extra metadata that I couldn't really figure out what was in that other than some extra metadata. But, so as you can see, we have here in the standard kind of model repository format. So when referencing this, we'll reference it as S3 OpenVINO QuartzNet 1 and then the different files underneath it. which we will see in just a moment as we go and create our model server. So now that we have this up there, we can use this model server to actually serve this over the internet. So we'll call it QuartzNet, we'll give it the S3 path. We're reshaping it because the input shape is changed from the default because of how we're padding the input data, and some other things like target device. And you can specify all of these through this really nice interface in the latest version of the OpenVINO operator. So let's go ahead and create that, not save that as a password. And if we look at our model server, we can see it spins up a whole bunch of stuff. And in our pod here, we can see that it has indeed loaded. Serving gRPC and REST. Changed our shape here. And now if we head back to here, we can do some inference against it. Let's see.
So Sean, what you're showing right now, you've got basically this is like a client example. So you're connecting back to the service that's running in OpenShift.
Yeah, so now that we've converted the model and we've uploaded it and we've started the model server, now we need to interact with it. So we have this OVMS client package, which wraps the gRPC calls that you can make against the OpenVINO model server. And we're going to show a couple of those. So the first one here is that we can get the model metadata. So you can see the inputs called audio signal, the output just called output, and we can see the input and output shapes. This 164, 176 from before, and the output shape of 188, 129. 26 characters plus a couple of extra things. And that they are also of data type float. So very useful when you're querying a server to know what's already deployed there. So after that, we're going to do a little bit of magic here to transform the inputs from just standard sound over to MEL spectrograms, which are converting the scale, doing Fourier transformations, and doing a whole bunch of other stuff that you can read about in either the blog post or the notebook. It's probably a little too in-depth for what we're doing right now, but there's a lot going on behind the scenes here to convert the input so that it's in a usable format. But as we can see, the audio shape is this here. We've padded a little bit so all of the individual time quanta are roughly the same size. And so we can now, with this OVMS client that we've created earlier, call predict against this model QuartzNet, feeding it in the inputs that we've created here. And now we can take and do some decoding. We have our alphabet, so that's the 29 different characters here. And we do a little removing of extra dimensions for batch size, etc. And if we look at the raw output, I've put together a slightly more raw version of the decoding algorithm just to kind of show what it thinks is happening at each time quanta. And you can see it's pretty well determined what we're trying to say because our input data is literally from the edge to the cloud, given that we were talking about edge and server and cloud server deployments earlier. And as you can see, using our decode here, this is kind of just a simple, remove duplicates type of decoding. And there you have it. We have our output. All of this can be found in single notebook format right here, and the original notebook can be found over here in OpenVINO Toolkit's OpenVINO Notebooks repository with the same type of stuff. Goes into a little more detail about what MEL spectrograms are and other things like that. So with that,
cool.
I guess.
Yeah, so anyone who's watching live and I think watching through the portal, there's a tab for handouts is what it's called, and it has links
Yes.
to there's an article that shows how you can repeat these steps, and there's also a link to the sandbox, so that if you want to try this out on OpenShift, you don't need to have an OpenShift account. You just need to sign up for a free Red Hat account, and you can go ahead and repeat what Sean just did. And so before we step over to Q&A, which if anyone has questions, please put them into the chat box, and or go to the Q&A section and we'll answer the questions. But Sean, when we think about the speech to text example, deploying an OpenShift, what are some of the applications where this would be useful?
Yes. So a couple of the applications, one that certainly comes to mind almost immediately for everyone is phone trees, I'm sure, because we've all had a case where we've had to talk into a phone tree. That's certainly one use case. Other things, note taking, etc., for individual users, since this could be deployed quite easily by an individual. There's also things like using this to avoid having to go over to Google's managed service for translations, since you could do these translations on your own infrastructure now. Chat bots, all kinds of other applications like that come to mind.
Nice. So there's one question that's about, can you use a custom speech recognition model? I'll go ahead and answer that. Sean showed in this demo how to use the QuartzNet model that's available in the Open Model Zoo, but for OpenVINO, if you want to go pull Wave2Vec 2 from Hugging Face, or if you want to use a different model that you trained yourself, you can do that. You just need to convert the model to OpenVINO format or have it in the Onyx format, and you can load it in and serve it just like Sean showed in the demo.
Yep. It works with pretty much any model. The default serving engine really wants to serve things in Onyx format or OpenVINO IR, but I believe the converter works with anything, right?
Yeah, the converter will take models that are in the Open Model Zoo, whether they're in TensorFlow, Caffe, MXNet, PyTorch format, and automatically run the script to convert it so that you don't have to. But if you're taking your own custom model, you can use the model optimizer tool and convert it to IR, or if you have an Onyx format, you can just load it directly into the model repository and start serving it. So another question about I already mentioned that you don't need to have OpenShift set up. You can use the sandbox. So there's a resource link in the handout section. Another is about OpenVINO running on Fedora and Red Hat Enterprise Linux like RHEL. So yes, OpenVINO runs on Red Hat, it runs on Fedora. The simplest way, if you want to get started on your laptop, is to just go to our documentation to install the developer tools, docs.openvino.ai. There's a section that tells you how to pip install the developer tools, but you can use almost any operating system, including Red Hat and Fedora. And another question about quantization. So in this, we did not show how to quantize the model, but we do have some examples, including ones that are available through the OpenVINO notebooks that'll show you how to take a speech-to-text model from Hugging Face, quantize it with the OpenVINO quantization tools. And then another, let's see, question for Sean. Oh,
okay.
Somebody also asked, can I use my own model? We answered that. Question for Sean, what can you tell us outside of speech recognition, what are some of the examples of how your customers, Red Hat customers, are using deep learning, using AI?
Let's see. Ooh, darn. The one that immediately came to mind, I don't think I can talk about.
So I
Let's
should
see.
change the question publicly that you can tell us about what are your customers doing?
Let's see. That's an interesting question. Sort of, I work more with partner integration rather than with the customers directly. Um, Although I know that there are a number of customers that have been looking at parallelization of training. So things like do things like that on top of OpenShift has been something I've been asked about a fair bit.
Nice.
So if you're talking about parallelization, you're talking about real big, real complex models. Let's see. I
Are
know.
these like the GPT kind of models, like Dolly, you're gonna
Yeah.
turn avocado armchairs or squirrels typing on computers or something like that?
Yeah, something of that scale. I don't know the specific details of that one per se. Let's see. I know that image recognition has been another one that's gotten a lot of interest, not just around regular image, but also around generating synthetic images for training as well has been something that's come up. So doing either segmentation on a generated image or recognition on a generated image.
Cool. All right. Well, thank you, Sean. So for everyone who's watching, there's a few resources in the handout section that tell you about OpenShift data science, and links to the sandbox and the code. So if you want to try it at home. And thank you, Sean. Look forward to continuing to work with you and the Red Hat team.